xenon fluorides, XeF2, XeF4, XeF6, xenon difluoride, xenon tetrafluoride, xenon hexafluoride, and the structure, hybridization. Okay, we are discussing. Next, shape of xenon fluorides. What is the shape? Okay, now what is the shape of xenon difluoride, xenon tetrafluoride, xenon hexafluoride? Okay, see the objectives. Okay, see the introduction. Okay, now see the introduction. See the introduction process. Helium, neon, argon, krypton, xenon, radon. You know that zero group elements are noble gases, are inert gases. Okay, okay, and eighth group elements, both are same. Eighth group elements are 18th, latest periodic table, 18th group. Okay, now old periodic table. So eighth group are zero group, are noble gases, are inert gases. Okay, now these are all comes under all same. So what are these elements here? Okay, so we are seeing helium is number 2, neon is number 10, argon is number 18, krypton number 36, xenon 54, and radon 86. These are atomic number and element. Helium, neon, argon, krypton, xenon, and radon. So these are the zero group elements. Atomic number 2, 10, 18, 36, 54, 86. So these are called zero group elements. So simple we are saying helium, neon. So see this line. Helium, neon, argon, krypton, xenon, and radon constitute the group of zero elements. They were not known at the time of classification by the elements of Mendeleev. Okay, at the time of Mendeleev introduced the periodic table. So on that time, the zero group elements are not known. But these elements came known to towards the end of 19th century. Okay, the early years of their discovery, they were not known to form compounds. Okay, now why the calls are zero group inert means the valency of zero group elements is zero. There is no positive and there is no negative. Okay, so there is only valency is zero. That's why they are called. They do not form any compounds with other elements mostly. So that's why they are calling inert gas elements zero group elements. Okay, according to they were placed in a separate group. According to they were placed in a separate group. It is designed as zero. Zero indicates why we are calling it zero. Why it is calling it zero? Because it indicates their chemical inertness or zero valency. Chemical inertness or zero valency. That's why they are calling zero group elements. Zero group elements. The elements are placed at the right hand extreme of the periodic table after halogens. You know that. So these are the periodic table S black. These 4 are D black, and these 6 are P black. This is D black, S black, and F black. Okay, now first, second group, third, fourth, fifth, sixth, seventh, and eighth. So these are the these are the right side of the periodic table after halogens. After halogens are seventh group A, seventh A group. These are zero group elements. Okay, now these are placed at right side of the extreme right side of the periodic table after halogens. After halogens, because this position is fitting in that the bridge gap between most electronegative halogens. Most electronegative halogens in periodic table is fluorine. You know that fluorine is highest, 4.0, fluorine, chromin, bromine, iodine. So these are called X. X means halogen atoms. X means halogen atom. Okay. So they clearly said that. So what are they saying? This position in fitting that the bridge gap between the most electronegative halogens and the most electropositive alkali metals. Okay, now first A group is most electropositive charge, and seventh A group is most electronegative. Most electronegative. Okay. With the determination of their atomic number and electronic configuration. So simple, the important one, this one, general electronic configuration is ns2np6. ns2np6. So this is in your fill in the blanks or the match the following. Okay, now this is an important bit question. ns2np6, general electronic configuration of zero group elements are noble gas or inert gas elements. Okay, now these are ns2np6. ns2np6. Okay, now these are the position of element in the periodic table is justified the view of electronic configuration. Okay, so these are so and so the introduction of zero group elements. Okay, now the introduction of zero group elements. So next one we are discussing the occurrence. Okay, now we are discussing about occurrence. Vinpistunda Pramod. Are you hearing or not?
Yes, sir.
Okay. So these are the important of occurrence. So occurrence. So what do you mean by occurrence? Means availability. Availability is known as occurrence in the atmospheric air. These are all are gases. Why they are calling inert gas elements? All are gases. See, as indicated, the earlier elements of helium. Okay, helium, neon, argon, krypton, xenon, and radon form a group of the zero period. Okay, na periodic table. With exception of radon, only radon, exception all this. What are they? Helium, neon, argon, krypton, xenon. All others occur in the atmospheric air, except radon. All available in atmospheric air. Okay, through a small extent, about 1%. Okay, na one below 1 or 1 equal to 1% is available in atmospheric air. What these zero group elements. Okay, now argon itself account of about 0.9. Argon is more available. Remaining radon is a radioactive element. Radon is nothing but radioactive element. Okay, now this is the occurrence of zero group elements. So what is the clearly point said that except radon, all the zero group elements available in atmospheric air about by 1%. In 1%, argon is 0.9%. Argon is more available. Okay, so discovery. With the discovery, Cavendish, the scientist, the Cavendish, well-known chemist, observed that atmospheric air contained about 1% of nitrogen like inert gas in 1892. Rayleigh experimentally observed that the density of atmospheric nitrogen is higher than the nitrogen prepared in laboratory. Okay, so these are. So you are observing that, okay, the 1% nitrogen is 1892 Rayleigh and a scientist. Rayleigh experimentally observed in his lab. Okay, so these are the some he named he could succeed obtaining the gas but could not night with the same because its chemical inertness. And Ramsay, a physicist, found this heavy inert gas to a new chemical element spectroscopy studies. He named it argon. Argon means lazy, inert. Okay, now argon means lazy, has failed to react with metals and caustic alkali, oxygen, and dichlorine. So these are not formed. Okay, now these zero group elements do not react with any other element. That's why they are calling inert gas elements. Okay, so these are the discovery, some elements. Okay, so important is isolation of noble gases from the atmospheric air. This was very, very important. Okay, now there are two methods are there. Fractionation of liquid air, and this one very, very important in your examination pattern. Adsorption on charcoal. How the isolation of zero group elements by the method adsorption of charcoal. Adsorption on charcoal. This method is very, very important in your examination pattern. Okay, there are two methods. See how the zero group elements is isolated from the air. See, simple. See the only source of noble gases. The only source of noble gases except radon. Why? The radon is radioactive element, not gas. That is radioactive element in the atmosphere. The isolation and separation chemical elements or compounds are generally affected, taking the advantage or difference of their chemical properties. So how they so something A, B, C is available. Okay, na? So A, B, C gases are available in your mixture. Okay, na? So we can isolate the separate like A and B and C. So based on their chemical properties, based on their physical properties, we can separate easily. Okay, now A melting point is 100, B melting point is 200, C melting point is 300. So we melt the mixture ABC. Okay, now A melted 100, we can separate this, and B melted 200 degrees. So based on the chemical and physical property, we can separate the gases or any like objects. We can separate easily based on chemical and physical properties. Something solid, something liquid, something gas, so and so. Okay, now based on physical and chemical properties. See this. This physical property is based on mass difference. Mass difference. Helium is different mass and argon is different mass. Krypton also different mass. Mass atomic number increase. Mass also increase. Atomic number increase. Mass also increase. Okay, na? So in atmospheric air, see this important point. In atmospheric air, the noble gases are mixed with. You know that in the air, 70-80% nitrogen is available. 20.09% oxygen is available, and remaining 1.1. Okay, na? Remaining 1.1. So all other elements are gases and moisture and dust particles available. Remaining 1%, CO2 is available. The zero group elements are available. Dust particle, moisture, so and so. Okay, so all available. This is the percentage of air in the atmospheric air. In the atmospheric air, 78% nitrogen, around 20. Okay, na? Around 20 to 21 oxygen is available, and 1% is 1.1, 1.2% is zero group or other total elements are available. So here the point is clearly showed that in the atmospheric, noble gases are mixed with oxygen and nitrogen, water vapor, and carbon dioxide. Okay, na? In the air, what are the elements are present? Nitrogen is present, oxygen is present, and water vapor, and CO2 plus zero group element. These are all the mixed. In atmospheric air. So we can separate, we can isolate from all the mixture the noble gas elements. Okay, na? In water vapor and carbon dioxide are the first removed. Okay, na? We are taking the atmospheric air. So first, which is removed? Water vapor and carbon dioxide are removed by their suitable chemical methods. Okay, na? Suitable chemical methods is removed by CO2 and water vapor. In first, the air is purified, is liquefied and fractionated. In other method, oxygen and nitrogen also removed by chemical methods. If you are using some chemical methods are available, we can use that method. We can remove oxygen and nitrogen also. Okay, na? So first CO2 is removed, then water vapor is removed, then oxygen is removed, then nitrogen is removed. The remaining what? Only zero group elements are available. See, by the chemical method, noble gases are subject to selective adsorption on charcoal and certain low temperature followed by adsorption and desorption. At low temperature, adsorption, and high temperature, desorption. Okay, na? Ravadam, velipod. Okay, na? Just coming. Adsorption means, so see the method. Okay, na? There are two methods to the separation. There are two methods for the separation of noble gases. Two methods for the separation of noble gases. Clear? Vintunara?
Yes, sir.
So, important question దీని నుంచి కన్ఫర్మ్ వస్తుంది లాంగ్ ఆన్సర్. ఓకే, నా ఫ్రాక్షనల్ రాకపోవచ్చు. నెక్స్ట్ అడ్సార్ప్షన్ అండ్ చార్కోల్ ఉంటుంది, అది కన్ఫర్మ్ లాస్ట్ 2-3 టైమ్స్ రిపీట్ అయింది. ఓకేనా? ఐసోలేషన్ మెథడ్స్ ఫర్ zero group elements by adsorption on charcoal. See, the fractional liquid air is simple method. See, the separation of compound in a liquid mixture is termed as fractionation. This fractionation is carried out in the case of liquid mixture by the method of fractional distillation. This procedure is based on the difference in boiling points. Fractional distillation, boiling points is different. You see that the name, what is the helium, is -268, neon 246, nitrogen 195, argon 185, oxygen 183, okay, krypton 152, xenon 108. So these are the boiling points. These are the boiling points of zero group elements. Okay, now based on the boiling point, we can separate the fractionation of liquid air. See, this process is based on the difference of boiling points of the liquid component of a liquid mixture. In efficient separation possible, the difference in boiling point between two liquid components, it at least 10 degrees difference is there. So at least 10 degrees difference is there. The boiling point data of component liquid air shows the except between oxygen and argon. Oxygen argon is just 2 degrees is different, but remaining all are minimum 10 degrees difference is there. Okay. More than 10 degrees between two components. Okay. Now, based on the boiling points, we can separate the zero group elements. Okay. So this is number one method. Okay. So this is important and conclude that. Okay. This is important. So 10 marks. This is important for 10 marks long answer question. What? Adsorption on charcoal. This is a chart is available. Adsorption on charcoal. The separation of noble gases of the atmosphere by adsorption technique. The separation of noble gases of the atmosphere by adsorption technique is based on the fact charcoal absorbs gases with different degrees of tenacity. Charcoal absorbs the zero group elements by the different degrees of tenacity depending on their atomic masses. The lighter gases absorbed with difficulty. The lighter gases is absorbed. For example, if you are using the duster and the chalk powder is absorbed on the duster, okay, na, that is adsorption. That is adsorption. You know that is adsorption. The lighter gases means, okay, na, mass is less masses elements, less masses gas is lighter gases, helium, neon, that is the lighter gas elements, argon, neon, they are lighter gas elements with difficulty degrees of tenacity, and they are also dissolved with great ease. Lighter gases are difficult to absorb and removed easily. But the heavier gases are strongly absorbed. At a given temperature. Adsorption gases can be dissolved by raising the temperature. Okay, na? Raising temperature will increase, the strong gases are removed. Okay, na? These are the adsorption and desorption method. After removal of, so starting with again atmosphere care. What the content atmosphere care? CO2 contain carbon CO2, water vapor, then nitrogen, oxygen, plus as well as zero group elements. All the elements are available in atmospheric air. So after removal, see this line, after removal of CO2, the water vapor, oxygen and nitrogen also removed by the chemical methods. Okay, after removal of the carbon dioxide and water vapor, oxygen and nitrogen also removed by the chemical method. Okay, the residual gases mixture contains only noble gases. The residual is contain only noble gases are present. What are the noble gases? Helium, neon, argon, krypton, xenon. Radon is radioactive. Okay, na? These are all atmosphere care present elements. These are all helium, neon, argon, krypton, xenon. These are all available in atmospheric air only, except radon. So see this line. The residual gases mixture contain the noble gases. It is passed into the Dewar flask. Important one. Okay, na, Dewar's method also named as Dewar's method also. Okay, na, they asked us what the Dewar's method for the adsorption on charcoal of isolation of noble gases. Write the Dewar's method. Okay, na, Dewar's flask containing activated coconut charcoal. Activated coconut charcoal cooled to minus 190 degrees centigrade. See this, okay na? So the noble gases are passed. and activated charcoal okay na. Cooled means less temperature. What the temperature is? minus 190 degrees. Minus 190 degrees. The charcoal is kept in contact with the gas mixture few hours for saturation. Okay na. They leave for the few hours for the adsorption. The charcoal is, the gases are adsorbed on the charcoal and the left for the few hours of saturation. After cooling, okay na, they left for the few hours for saturation. At minus 190 degrees, the charcoal absorbs all the noble gases. At minus 190, the charcoal absorbs all the noble gases. The unabsorbed gases are pumped out. So which are unabsorbed on charcoal? They are pumped out to the outside. Okay. The flask is then gradually warmed. Okay na? The flask, Divar's flask is gradually warmed up to minus 100 degrees centigrade. Minus 190 to minus 100 degrees centigrade. When helium, neon and lighter element numbers get dissolved first. Okay na? Enduku? So, ikkada chudandi. 100 degree దగ్గర helium, neon. Okay. Helium, neon. ikkada chudandi. Helium, neon. When helium, neon, lighter numbers get dissolved first and leave the charcoal. First helium, neon anadi bayatiki velipothayi. Then the gas mixture is pumped into another Divar flask. The two elements are dissolved, containing charcoal kept cooled at minus 180. Okay na? If temperature increase chesina malli endi cool chestunnam. Okay na? They again cool into minus 180 degrees. At this temperature minus 180, neon alone is adsorbed. Only neon will adsorb at minus 180 degrees. The unadsorbed helium is pumped out. Unadsorbed helium is pumped out. Neon is dissolved by heating on charcoal. Okay na? So ingem vellipoyindi helium. Ikkada em vellipoyindi first neon is gone outside. Okay na? The unadsorbed helium is pumped out. Neon dissolved by the heating of charcoal. The Divar flask containing charcoal with adsorbed argon, krypton and xenon is available. The two are dissolved. Helium is dissolved and neon also. The remaining what? Argon is, krypton and xenon. At 180 degrees, consider another flask charcoal at minus 180 నుంచి మళ్ళీ ఏం చేస్తున్నాం? Cooling to minus 190 degrees. Under this condition, lighter number of argon flows over into the second flask. Argon, krypton, xenon. Based on in this, only argon is lighter element when compared to krypton and xenon. Under these conditions, the lighter members of argon flows over into the second flask where it is adsorbed on the charcoal at minus 190. So argon is separated by the warming of charcoal. The flask containing charcoal with adsorbed krypton and xenon. Remaining argon is removed. Krypton and xenon is available. Warmed up to minus 80 degrees. 180 to minus 80 degrees. So finally, xenon is separated further the warming. Xenon is separated further by the warming. Okay. So these are the adsorption on charcoal, separation of zero group elements by the Divar's flask method. You see this. Okay na? You see the chart. Okay na? The chart is very important. Okay na? You have to write in your exam just chart enough. So noble gas mixture. First noble gas mixture on the processor comes under with the chart. See simple activated coconut charcoal. Okay na? First వినిపిస్తుందా? Yes sir.
Yes sir.
సో ఇది ఇంపార్టెంట్ క్వశ్చన్, కన్ఫామ్ గా ఎగ్జామ్ లో వచ్చే క్వశ్చన్. డివార్స్ మెథడ్ అన్న అడ్సార్ప్షన్ ఆన్ చార్కోల్, ఐసోలేషన్ ఆఫ్ నోబుల్ గ్యాసెస్ బై అడ్సార్ప్షన్ చార్కోల్ మెథడ్. ఓకేనా? యూ హావ్ టు రైట్, యూ హావ్ టు డ్రా ది చార్ట్. ఓకేనా? టు యూజ్ ఇట్ టు రైట్ ద మ్యాటర్. ఓకేనా? ఫస్ట్ we are introduced the noble gas mixture into activated coconut charcoal at minus 190. It cooled into minus 190. So you know that 0 degree is how the cool ice cube. minus 190 means heavy cool, minus 190 degrees. Okay. And so if we are introduced the noble gas into activated coconut charcoal, simple unabsorbed gases are pumped out. Okay, na something we are sending 5 to 6 gases. Okay, na 3 to 4 absorbed, remaining 2 are pumped out. Remaining 2 are they go exit. So outside. Then absorbs helium, neon, argon, krypton, xenon. The activated charcoal is absorbs the 5 gases. Okay, na temperature raised to ante minus 190 degree to minus 100. Okay, na minus 190 to minus 100 means this is more. Okay, na heating. Okay, na there is more temperature raised into minus 100 is when compared to minus 190 it is more. You know that. Then charcoal at 100 degrees. Charcoal at minus 100 degrees. Argon, krypton, xenon. Argon, krypton, xenon is separate and neon, helium is dissolved. Neon, helium is dissolved. So neon, helium passed into charcoal again 180, minus 180 degrees, again cooled. Okay, na. So when the neon absorbed charcoal minus 180, see. Okay, so neon minus 180. So again warm up. Okay, na again warm up just in the neon anedi dissolve ayipotadi. Helium not absorbed, so it is removed. Okay, na pass into charcoal minus 180 degrees. Helium is not absorbed. Okay, na helium is not absorbed, so that's why they removed easily. So remaining mixture are content. What are the content? Helium, argon, krypton, xenon. So charcoal minus 100 degrees with argon, krypton, xenon. The raise the temperature, cool the temperature up to again minus 190. So argon flows out. Argon flows out. Absorbed on charcoal at minus 190. Minus 190 దగ్గర ఏంది అది అబ్జార్బ్ అయిపోతుంది charcoal పైన. So krypton, xenon, charcoal at 100 degrees. అవి అక్కడనే ఉంటాయి. Okay. Then minus 190 we can warm up. Argon was dissolved. Adsorption అతుక్కోవడం, dissolve మాత్రం బయటకు వెళ్ళాలి. సింపుల్ గా చెప్పాలంటే. Okay. Raise the temperature again minus 80 degrees. Okay na? Raise the temperature again minus 80 degrees. Krypton is dissolved. Krypton is dissolved. Helium on charcoal at minus 100 degrees. Again we warm up. Okay na? Again we raise the temperature. The simple xenon also dissolves. Okay na? This method is useful for the adsorption on charcoal. Okay, charcoal method. Very, very important. Okay. అర్థమైందా? See, next one, properties of elements. Okay, na? These are all the properties, but you have to remember these elements and atomic number, electronic configuration. Okay, na? Helium, you know that helium, you are observing that helium only 1s2, atomic number 2. Neon 10, 1s2, 2s2, 2p6. So just we have to write simple. If we are using neon, helium 2s2, 2p6. If we are writing argon, neon 3s2, 3p6. Okay na? If we are writing for krypton, argon 3d10, 4s2, 4p6. Simple ga cheppalante. Okay, simple ga. So the electronic configuration is, general electronic configuration is ns2, np6. Just the helium is only 1s2. Okay na? Neon వచ్చేసి 2s2, 2p6. Argon 3s2, 3p6. Krypton 4s2, 4p6. Xenon 5s2, 5p6. Radon 6s2, 6p6. Final electronic, outermost electronic configuration, all the electronic configuration is ns2, np6. ns2, np6. Okay, these are important for the electronic configuration for the every zero group element. Okay. Next, atomic mass 2 unte exactly double. Okay, exactly double. 2, 4, 10, 20, 18, 39 means double or more than double. Double కంటే కొద్దిగా ఎక్కువ 36, 83, 54, 131, 86, 222. Okay. So these are the boiling points. Simple. It boils at 4 degrees. Just 4 degrees. Sorry. 4.2, 27, 18, 87, 120. Okay, na? Melting point 0.9. So see the first ionization in the density and 0.1786 density. Helium, neon 0.9002. Okay, very less density. Okay, na? See the property series. They are all colorless and odorless gases. Okay, na? The zero group element gases are colorless and odorless gases. They are very slightly soluble in water. They are very slightly soluble in water. They are monoatomic gases. Monoatomic gases. The boiling points increase with increase of atomic weight. The boiling point increase with increase of atomic weight. Okay. Then because of the fact they do not show any tendency to form compounds. However, they were reported they form compounds like substances under special conditions. Okay. So these are the some important chemical properties. Important is uses. What are the uses and structures of noble gases? Only from this lesson, adsorption charcoal method is number 1 question. Use of noble gases and structure of xenon chlorides. These are 3 questions are come from this lesson, your examination pattern. Okay, adsorption method, uses of noble gases, and structure of xenon fluorides. Structure of xenon fluorides. Okay, see uses. Okay, now you generally outside. Okay, now the boards are there. The lightning boards. Okay, now the lightning boards are available. Okay, so for the simple for advertisement, you know that advertisement boards. Okay, na, you know that advertisement boards are available. In that boards, they are lighting. Okay, na. So simple. See, the helium is lighter than air and is non-inflammable. Helium. So we are expecting about helium is lighter element. Okay, na, lighter element and air kante takwa, non-inflammable. It is therefore used in the place of hydrogen for filling of meteorological balloons. You know that helium balloons, they are okay. So they high in the range. Okay, now the helium balloons. Okay, now helium balloons. A mixture of helium and oxygen is used for the respiration by the deep sea drivers. You know that deep sea drivers are under sea. So oxygen levels are less. Okay, now oxygen levels are under the deep sea very less. Okay, na. So they bring, okay, na. So they bring the oxygen cylinders. Okay. So in the oxygen cylinders, what is the mixture of helium and oxygen is used for the respiration. Okay, na. In deep sea, the oxygen levels are less for the respiration. Okay, na. Breathing is so very difficulty in breathing. So that's why we are using helium and oxygen for the respiration by the deep sea divers. Less soluble in blood than nitrogen. Less soluble in blood than nitrogen. It is employed to provide inert atmosphere to prevent the oxidation of metal surface during the welding active metals. Okay. Next to neon. Neon is used in the discharge tubes for the illumination of decorative lighting. Decorative lighting available in the outside in the shopping malls and the boards in the back opposite. Okay, a number of decorative boards are there for the lighting. Okay, neon gas is given to orange red glow in discharge tube and neon sign are used for the advertising. A mixture of neon with argon and mercury vapor discharge tube emits a blue light. Okay, argon used in the filament in electric bulbs and radio walls and tubes. Since it is inert and so prolong the life for the device. Okay, it is also used in the Geiger counters. Okay, and krypton, xenon are more efficient than argon. Incandescent bulbs and Geiger counters. A krypton xenon mixture used in the photo flash bulbs for the instant photography. Radon is used as the treatment of certain cancers. Okay, now radon is used for the certain cancers. It is also used as substituent for the X-ray in industrial radiography. X-ray la kuda use chesaru. Okay, now these are the uses. for the noble gases. These are the uses for the noble gases. Okay. Vintunara, Hima.
Yes, sir.
Okay, then questions. Askunara, adsorption charcoal method okati, uses of noble gases, and these are the structures. These are the structures. XeF2, XeF4, XeF6. 3 questions are very, very important. Only 3 questions. Okay. See, uses of noble gas or structure of xenon chloride. See that. So this is the box. Okay, na? This is the box shape of xenon chlorides. XeF2, XeF4, XeF6. So total number of electrons 10, 12, and 14. Okay, na? So see the electron pairs 2 plus 3 pi. So now just structure trigonal bipyramidal, octahedral, pentagonal bipyramidal, lone pair, equatorial. So just structure linear, square planar, and distorted octahedral. Square planar, distorted octahedral. Just okay, na? So this is for the XeF2, xenon difluoride. Xenon difluoride. See the xenon is xenon. Okay, S2P6. NS2NP6. Everyone NS2NP6. Xenon and radon. Atomic number is 54. Xenon the okay na NS2NP6. 4D10, 5S2, 5P6. So here ground state NS2NP6. Ground state NS2NP6. In excited state, okay na XeF2. Okay, na, in excited state, the 1 electron in p orbital is jump into d orbital. So the involvement of sp3 hybridization, sp3d hybridization, because see this, a simple saying like xenon, how many 8th group elements is there? 8 electrons is available. 1, 2, 3, 4, 5, 6, 7, 8. So fluorine carries 1 and 1, 2, 3. Okay, na? 3 lone pairs, 2 single electrons. 3 lone pairs, 2 single electrons. Okay, na? See this, simple. We are saying like 3 lone pairs, 1, 2 single electrons. 3 lone pairs, 2 single electrons. If 5 available, sp3d hybridization. If 5 available, sp3d hybridization. sp3d hybridization. So what? See, like the structure is F, lone pair, and lone pair. So this is the structure of XeF2. So simple structure ఒకసారి రాస్తున్నాను మళ్ళీ. Xenon, F, lone pair, and lone pair. Okay, so this is the structure of xenon difluoride. Okay, na? Simple. You draw the structure like this, and hybridization, sp3 hybridization. Okay, so structure is shape is linear. What you write? XeF2, xenon difluoride, sp3d hybridization, and linear structure with 3 lone pair of atoms. Linear structure with 3 lone pairs of atom. 3 lone pairs of atom. Okay, so this is first excited state. Okay, na? This is first excited state. See, in XeF2, there are 2 XeF bonds are required, 2 unpaired electrons. 2 unpaired electrons. They can be obtained by the unpairing of 1 outer pair of electron in the p orbital and promoting 1 electron into d orbital. Promoting 1 electron into e electron d orbital. Okay, na? So the atomic orbital undergo trigonal bipyramidal hybridization. If the 2 axial hybrid orbitals are used to bonding with the 2 fluorine atoms and other 3 equatorial orbitals are filled with lone pairs. According to this, the shape of the molecule is linear. Okay. Then we are discussing about xenon tetrafluoride. Okay, na? So another, okay, na, there are NS2, NP6, same. Okay, na? If there are 2 electrons, another 1 electron, P Okay, now px, py, pz. So p electrons are excited state configuration. Another one electron is jumped into the d orbital. Jumped into d orbital. So here simple. Okay, xenon 1, 2, 3, 4, 5, 6, 7, 8. 4 orbitals using 4 electrons and remaining 2 lone pairs. Remaining 2 lone pairs. So that's why we are saying like simple, the structure is xenon 1 fluorine, 2 fluorines, 3 fluorines, 4. Okay, sp3d2 hybridization. sp3d2 octahedral is available, but two lone pairs are occupied in this. So that's why these are called, the structure is square planar. XEF4, the structure sp3d2 hybridization, square planar with 2 lone pair of electron. So this is XEF2. Okay? అర్థమైందా? Finally, XEF6. Okay, now the other p electrons jump into the another d orbital. See, 1 lone pair, 6 single electrons. See the structure. Simple. You are observing that XEF, Okay, now this is empty. 1 lone pair. So this is distorted octahedral or octahedral wedge. Okay, simple గా చెప్తున్నానండి. XEF2, XEF4, XEF6. XEF2 sp3d, sp3d2, sp3d3. ఓకేనా? ఇదేంటి హైబ్రిడైజేషన్. sp3d2. స్ట్రక్చర్ వచ్చేసి లీనియర్, స్క్వేర్ ప్లానార్, డిస్టార్టెడ్ ఆక్టాహైడ్రల్. ఇది గుర్తుపెట్టుకోండి. ఓకేనా? XEF2 sp3d hybridization, linear structure. XEF4 sp3d2 hybridization, square planar structure. XEF6 sp3d3 hybridization, distorted octahedral structure. Okay, then the structures like, ఓకేనా, ఈ స్ట్రక్చర్స్ గుర్తుపెట్టుకోండి. ఓకేనా? సో XEF2 ఓన్లీ 3 lone pairs, XEF4 2 lone pairs, XEF6 1 lone pair. Okay, simple method. Okay, now these are the zero group elements, structures of xenon fluorides. Clear? అర్థమైందా?
Yes, sir.
సో ఇవి సార్ ఈ 3 క్వశ్చన్స్ మాత్రమే ఎక్స్పెక్ట్ చేయడానికి ఉంది ఇందులో నుంచి. ఓకే, సింపుల్ అబ్జార్ప్షన్ మెథడ్ యూజెస్ సింపుల్. ఇది 3 స్ట్రక్చర్స్ గుర్తుపెట్టుకోండి. అండ్ హైబ్రిడైజేషన్ అండ్ షేప్. వాట్ ఈస్ ద షేప్? XEF2 విచ్ షేప్? లీనియర్. ఓకేనా? XEF4 స్క్వేర్ ప్లానార్. XEF6 distorted octahedral. ఓకేనా? sp3d, sp3d2, sp3t3. సో లాస్ట్ టైం వచ్చిన క్వశ్చన్స్ ఈ 2 క్వశ్చన్స్ రిపీట్ అయినా. ఓకేనా? యూజెస్ ఆఫ్ నోబెల్ గ్యాసెస్, షార్ట్ ఆన్సర్. దెన్ స్ట్రక్చర్ ఆఫ్ xenon fluorides. ఓకే, సో దీస్ ఆర్ ది zero group elements. What are the zero group elements? Helium, neon, argon, krypton, xenon, radon. Except radon, all are gases, sir. Except radon, all are gases. Okay, na? All are available in atmospheric air. Except radon, because radon is a radioactive element. Okay, so atomic numbers 2, 10, 18, 36, 54, 86. Okay, na? 54, 86. Simple, we are saying general electronic configuration NS2,
NP6.
NS2, NP6. General electronic configuration is NS2 NP6. Okay. See the question. Okay, these are the questions. Despite the existence of noble gases as monoatomic species, why do fluoride, xenon exist? Fluorides, argon are known. So, it's a question. So, direct discuss, examine the isolation of noble gases by the liquid air, fractional distillation method, and charcoal adsorption. Charcoal adsorption is very, very important. Okay, then uses of noble gases, then xenon fluoride structures. Okay, na? These are very, very important. Okay.
Okay, sir.
So these are the zero group elements. The remaining continue tomorrow. So zero group is complete. 6th group also complete na. Interhalogens last class. Winnara? Interhalogen compounds. Okay. We are discussing about, okay. So in this lesson, physical chemistry, we are discussing a physical and general chemistry. Okay, in this liquid state, colligative properties and colligative properties 2. Okay, na? Osmotic pressure. Okay. Then general chemistry, radioactive. These are nuclear chemistry. In this, 3 lessons are there: nuclear chemistry, colloids, and adsorption. Colloids and adsorption. Okay. So in nuclear chemistry, simple the less. So these are the important, sir. Nuclear reactions. Okay, na? Just take screenshot. Nuclear reactions. What is spallation and what is nuclear fission and nuclear fusion? Okay, na? Reaction in which nuclear undergoes spontaneous change or interact with other nuclei, forming a new nucleus. And other lighter particles are known as nuclear reactions. Okay, na? In such reactions, both atomic number and mass number are conserved. In the different ways, spallation. Okay, na? In this type, the nuclear reaction is heavy nucleus break into small fragments with atomic number 10 to 20 units. Okay, na? So heavy nucleus is break into the so small components. For such reaction, high speed and high energy projects about 400 MeV electron volts. Okay, na? Mainly macro electron volts are needed. See the copper, 29 atomic number, 63 atomic weight. Okay, na? It react with 2 helium. Okay, na? Helium, it react with helium isotope. So they break into Cl 1737, 14 protons and 14 neutrons. Okay, na? 14 protons and 16 neutrons. They break into small pieces. Okay, na? So spallation and nuclear fission, nuclear fusion. What is nuclear fusion? And also the radioactivity of theory rate. Okay, na? So the important is what is half-life and radioactive element. Next, radioisotope uses. Okay, na? Radioisotope uses, these are very, very important. In radioisotope in reaction mechanism lo ela use aitay, radioisotope agriculture, radioisotope medicine, radioisotopes in industries. So you know that medicines, radioiodine is used for the cure thyroid glands, and sodium is used as the direct defense of circulation of blood. Phosphorus P32 used for the cancer, locating cancer. Okay, na? So radioisotope in age of rocks, minerals, carbon dating, radioisotope analysis of radioactive. Very, very important question. In this long answer question, radioisotopes use spallation, nuclear fusion, and half-life. What is half-life? Okay, na half-life. The half-life of the radioactive element. Okay, na these are very important. Okay, so we are discussing about tomorrow, same time, 10:30. Tomorrow is the last class. Okay, I have already given important questions. Yes.
Yes, sir.
Yes.
Okay, so just you tell me.
It's me only, sir. I have asked questions to you. Important.
Tell me.
Sir, I have one doubt, sir. Regarding oxy acids, I haven't understood, sir.
Oxy acids.
Yes, sir.
Oxy acids are which one? Sulfur.
Yes, sir.
Which one? Sulfur?
Sulfur only, sir.
Peroxides or oxy acids?
Oxy acids, sir. Oxy acids only. Page number 18, sir. Second paragraph.
Okay, this one.
18 page. Yes, sir. That second paragraph I haven't understood.
Second paragraph.
Yes, sir.
In most of the oxy acid, acidic proton is bound to an oxygen, which is turned like into central atom. Okay, now here M means metal. MOH. M means metal. Depending upon the oxidation state, the electronegativity of central metal atom M, the acidities of oxidation state and electronegativity of the central atom M, and acidity of oxygen. Okay, now oxy acids, depending on the metals, the oxidation state is different. The oxidation state is different. Some generalized have been possible to the record. For instance, the central atom in low oxidation state, example in H2SO4. You know that H2SO4. So central metal atom, low oxidation state, sulfur in H2SO4. Proton finds an additive electron density on the oxygen. Okay, fairly strong. This paragraph will tell tomorrow. Okay, na? So how the writing is simple method H2SO2, H2SO3. Okay.
Yes, sir.
So how many hydrogens are there? Equal to OH bonds are available. Okay, na? Here we are taking first one. H2SO2, there are 2 hydrogens, 2 oxygens. If there are sulfurous acid, H2SO4, H2SO3, 2 OHs bond available, the remaining is double bond O. Okay. See, so how the 4 is means why the oxidation is a coordination number only to oxidation state, not coordination number. So this is O, oxygen is -2, OH minus, OH minus. So -4 is equal to silicon +4. Okay. So we'll express tomorrow the oxy acids of sulfur. Very, very important. Okay.
Okay, sir.
Okay, right. Thank you. We'll meet tomorrow, last class.
Okay. Thank you, sir. Hey!